Let us look at proposition number 59 of book 10 of Euclid's Elements. The proposition says, if an area is contained by a rational straight line and the sixth binomial, then the side of the area is the irrational straight line called the side of the sum of two medial areas. Let's proceed and try to prove this, and in the process we'll understand what this proposition is talking. Okay, let the area AC be contained by a rational straight line AB and a sixth binomial line AD. Divide AD into its terms at E so that A is greater than ED. Purely based on the definition of sixth binomial line, we can say AE and ED are rational straight lines commensurable in square only. AE square is greater than ED square by the square on a straight line incommensurable with AE. AE and ED are incommensurable in length with AB. So these three statements are purely based on the definition of a sixth binomial. Okay. Now let's bisect ED at F. Apply to AE a parallelogram AG by GE equal to EF square. So once we apply, basically we are interested in this point G. But when we actually do the detailed construction, we will end up drawing a rectangle. Okay, so what this means based on the proposition 18 of book 10 is that AG is incommensurable in length with GE, and now we draw GHEKFL from GEF parallel to either AB or CD. So basically we draw lines from G, E and F parallel to AB or CD. Now construct Sn equal to AH. So we have to draw a square Sn so that its area is equal to AH. Next, we draw another square NQ equal to GK. And we draw it in such a way that the square sits on this line MN from N. Now we complete the parallelogram SQ. Based on the lemma, we know that SQ is also going to be a square. AG by GE is equal to EF square. This can be written in proportion form as AG is to EF equal to EF is to G. So which means AH is to EL is equal to EL is to GK. How? Because AH is a figure on AG, EL is a figure on EF, and GK is a figure on GE, and they are all between the same parallel lines. So which means EL is a mean proportional between AH and GK, which means EL is a mean proportional between Sn and NQ because AH is equal to Sn and GK is equal to NQ. And based on the lemma, we can say MR is also a mean proportional between Sn and NQ. Means EL is equal to MR is equal to PO as well because MR is equal to PO. So now AH plus GK is equal to Sn plus NQ because AH is equal to Sn and GH is equal to GK is equal to NQ. The remaining part of the square also will be equal. So that means MR is equal to PO, EL is equal to FC because again F is the midpoint. So since this brown and green is equal to brown and green, that means this pink part is equal to this blue part. Let me put it that way, which means AC, the rectangle area, AC is equal to the square SQ. And the square SQ can be written as SJ square, or we can also write it as MO square because MO is equal to SJ. So that means MO is the side of AC, or more appropriately, MO is the side of the square whose area is equal to the area of this rectangular area AC. Okay, now let's proceed. We have proved that MO is the side of AC. AG is incommensurable with GE. That means AH is incommensurable with GK because AH is the figure on AG and GK is the figure on GE. And since AH is equal to SN and GK is equal to NQ, AH is incommensurable with GK, so is SN with NQ, which means MN and NO are incommensurable in square because SN is equal to MN square and NQ is equal to NO square. So we have proved that Mn and No are incommensurable in square. Now, since AD is a sixth binomial line and ED is less than AE, AE is incommensurable in length with AB. So AE by AB is equal to AK is medial, which means Mn square plus No square is medial. AE by AB is nothing but AK, and AK is equal to Sn plus NQ, which is nothing but Mn square plus No square. So it is medial. Now ED is incommensurable in length with AB. ED is commensurable with EF. That means EK is incommensurable with EF because ED is incommensurable with AB, that is EK, and ED is incommensurable with EF. Therefore, EF is incommensurable with EF. That means EF and EK are medial, so that the area contained by EF and EK is also medial. So MR is also medial. Why? Because EL is equal to MR. So Mn by No is medial. Since MR is contained by Mn and NR, but NR is equal to NO, so Mn and No is the straight lines which contains the area MR. And MO is nothing but Mn plus No. So MO is the side of a medial plus a medial area. So that was proposition number 59 of book 10 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.